Alright, so now I'm gonna talk about the prior, the likelihood, and the posterior. I just want to make sure that you understand the concept and the definition of the prior, the likelihood, and the posterior. Well, yeah, this is in the homework number 3. Yeah, because this is a very important concept in machine learning and in also statistics. I guess you will see these kind of things a lot more in the future in the lecture, okay? So for the prior is like the probability when you get something. Say like suppose that your friends just hold a fruit in his hand, and then he just hide it from you, right? And then he asked me, okay, he asked you like, okay, what is it? It should be orange or the apple. And then you realize that, okay, maybe in the spring, maybe there's no orange in the spring. So what you guess is that he will hold the apple in his hand with this probability 0.8, and it's going to be orange with 0.2, because in this season you think that there's very few very few oranges in the market and a lot of the apples in the market. So that's why without any information about the dimension of the fruit or the color of the fruit, you just guess the probability like this. So this is called the prior. So basically the prior is what you guess or what you can or what you feel from experience. You try, this is like the attempt to try to get something out of your experience, out of your feeling, and some information that you heard it before, something like that. So this is called the prior. So and the likelihood, basically it means like if you have the data X and you have the distribution of this class omega J, and then you would like to see how the data X match with the distribution. That is called the likelihood. And actually the likelihood, you can write it down like this: the likelihood of the omega J given X, the data X, okay? And actually this thing can write down in this form of the probability. So it is the probability of X given omega J. I will explain later why we can write down like this. And the last one today is the posterior. The posterior is the probability that you will guess that once you get the information, right? Once you get the information X, so what is the class that you guess that X should be in? Okay, the thing is, when you have the prior, you have only P of omega J, right? And then without any information, right, you just guess it's from like the state of nature or some knowledge that you have already. But once you have some measurement X, you can add the X to it, right? So this is called the posterior. So basically it combines what you know already and the measurement that you gain from from your friends or from whatever measurement that you have, okay? All right. So, like in the homework number 3, you are given with 2 classes of the data, okay? So maybe this is called the class 1, okay? And then you have another one in the black bin. It's called the class 2, okay? And basically, you have the feature space. Here is just 1D feature space, okay, called X, all right? And then the first thing we have to do is to do the histogram, right? So suppose that I draw the sample from the class 1. I draw it 3,000, right? And then for the class 2, I draw the sample from here 2,000. samples, right? And then I will plot the data from the class 1 in this feature space. So I plot it here, okay? Suppose this is what I plot. So you see, suppose that the data is very dense right here and very sparse when it far from the center here. And for the class 2, also do the same thing. I just plot the data on this axis, okay? So like this, all right? Then to make the histogram is easy, right? You can just determine the width of the bin, and then you just apply it to here. Then you get the histogram like this, and apply it to the class 2 too. So like this, okay? So actually this one should lower, right? Because should be okay. So this one is the frequency, right? Frequency. It means that how often that what is the number of the data that fall into a particular bin, okay? So basically this is the histogram. It's gonna be like the bars and like this, and this too, right? And basically I call this H1, histogram 1, which is a function of x, and this is called the histogram 2, which is the function of x as well. So if I sum all the thing here, all the histogram, I mean the height here, right? If I sum the height here again is just the frequency, right? It's just the number of the point that fall into a bin, right? If I sum it, h1x sum over x, okay? This is x, and again I sum here, so it's gonna be 2000, right? This one, and for histogram, the one here is gonna be 3000, right? Okay, so this is called the histogram. But the thing is, from the histogram we can normalize it so that we can get the likelihood, okay? So basically, if you just use this number and then do something like this, and this is again do something like this, then you will get something out of it, right? I call it h.2 x of x, okay? And this is again, it's called h1 prime x, okay? And basically this h1 prime x and h2 prime x is the likelihood, right? And so it's the likelihood because when we sum it, I just use this one, okay? When we sum this one, right, and when we sum this one, it's gonna be 1, right? It's gonna be 1 right here. And actually when you divide the original histogram by the total number of the data in this distribution, actually the curve, the shape of the curve gonna be pretty much the same, but basically it will change according to relatively to another distribution. Like suppose in this one, once you divide by this, I believe it's gonna be higher a little bit, okay? Yeah, something like that. So this one, so the result of doing the normalization here is called the likelihood, okay? This one. So how about this? I will write this as P of x given omega 1, right? Because this is from the class 1, and this is P of x given omega 2, because this